Up until the last lesson, we practiced connecting information from neighboring place values to determine or narrow down values. In this lesson, through two challenging problems, students will experience that even an established algorithm can have loopholes. They will learn that by observing the place values more closely, these loopholes become visible, and their algorithms become more refined through such observation. Focus on what the student missed and rediscovered, rather than solely on getting the correct answer. In problem 1, it is easy to miss that there are two possibilities. I plus 2 equals 10 and 20 within the condition when the carryover is 2. In problem 2, the key is for students to realize on their own that they were taking the assumption the carryover can be at most 1 for granted. Both problems may take time. Please do not rush and give them plenty of time to think.
I solved it.
Please share what you observed for each place value and how you solved it.
X in the hundreds place is 1 or 2. Since we added 3 numbers to get a carryover, if we think about 3 times 4 up to 3 times 9, the carryover can be 1 or 2.
Is there anything else you can figure out from the tens place?
The sum of I plus I carries over to the hundreds place. But we have to think about whether there is a carryover from the ones place first.
What can you figure out from the ones place?
We added the same number 3 times. If there is a carryover, it has to be 1 or 2.
Can you tell for sure if there is a carryover or not?
I can't tell if there is one yet.
So what did you do?
I broke it down into 3 possibilities.
Can you explain those 3 possibilities?
I checked when there is no carryover, when the carryover is 1, and when the carryover is 2. If there is no carryover, I plus I equals 10. So, I is 5. But for the sum of 3 v's to end in 5, v has to be 5. Since I and v would be the same digit, I'll cross this out. If the carryover is 1, I plus 1 equals 10. I plus I cannot be 9. So I'll cross this out too. If the carryover is 2, I plus 2 equals 10. So I is 4, x is 1, and v is 8.
Amazing! You solved a problem that even AI gets stuck on. However, there were a few gaps in your thinking. You checked things you didn't need to, and you missed a part that needed checking, even though it didn't change the final answer. Let's review it together and find them. Your observation of the hundreds place was great. In the tens place, we can't be sure exactly what I plus I is. But since it's the same number added twice, is there something you can say for sure?
It's an even number.
Then, if there is a carryover from the ones place, what must it be?
It must be 2.
Can you explain why it can't be 1?
I plus I is even. But if a carryover of 1 comes from the ones place, the sum becomes odd. I plus 1 equals 10. But I plus 1 would be an odd number.
Perfect. But when the carryover is 2, is I plus 2 equals 10 the only one?
It could also be 20. If I plus 2 equals 20, I should have also checked when I is 9.
What happens if I is 9?
If I is 9, x is 2 and v is 3. But if v is 3, there is no carryover from the ones place. We started with a carryover of 2, but it didn't even happen. So, I equals 9, I'll cross this out.
Great job! You broke the carryovers down into 0, 1, and 2. But you just figured out that we had to split carryover of 2 into smaller parts. See? When you look closer, you can find things you missed at first. Please look at each place and share what you observe.
I'll start with the thousands place. It's b plus b. And since no new place was created in the result, there is no carryover. So, b is 4 or less. The hundreds place is c plus c. But the result in the hundreds place is also c. For a number to be added twice and result in the same number, it has to be either 0 or 9.
Can you tell which one it is right now?
No. It depends on whether there is a carryover from the tens place. If there is a carryover, C is 9. If not, C is 0.
Good. Shall we look at the tens place then?
It is D plus D, and the result is also D. It's exactly the same as the hundreds place. D is also 0 or 9. Wait, something is weird. If D is 0, there is no carryover to the hundreds place, so C is 0. Then C and D become the same number. If D is 9, a carryover is created so C is 9, but C and D are the same number again. Neither works, so something must be wrong.
Did you make that judgment by looking only at the tens place? Did you try connecting it with its neighbor?
I haven't looked at the ones place yet. I know what I missed. In the ones place, it's A plus E plus E, and the result is E. A plus E gets carried over to the tens place. And since it's the sum of 3 numbers, the carryover can be up to 2, not just 1.
Why did you only think of 1 at first?
Usually, when we add 2 numbers, the carryover is at most 1, so I guess I just thought it was always like that.
Let's sort out the tens place again.
The carryover plus just needs to be 10. Whether the carryover is 1 or 2, carryover of 1 goes to the hundreds place.
Now you can find the hundreds place.
Since it received a carryover, C is 9. D cannot be the same number as C. Then D is 8, and we can find out that the carryover from the ones place is 2.
Let's move to the ones place and find A and E.
Okay, A plus E is 20. But since C is 9 and is 8, A and E must be the 2 largest remaining numbers to make 20. 7 plus 6. A is 7, and E is 6.
Well done!
I know what I missed. In the ones place, it's a plus e, and the result is e. A plus e gets carried over to the tens place. And since it's the sum of three numbers, the carryover can be up to 2, not just 1.
Why did you only think of 1 at first?
Usually, when we add two numbers, the carryover is at most 1, so I guess I just thought it was always like that.
Let's sort out the tens place again.
The carryover plus just needs to be 10. Whether the carryover is 1 or 2, carryover of 1 goes to the hundreds place.
Now you can find the hundreds place.
Since it received a carryover, C is 9. D cannot be the same number as C. Bend is 8, and we can find out that the carryover from the ones place is 2.
Let's move to the ones place and find A and E.
Okay, A plus E is 20. But since C is 9 and is 8, A and E must be the two largest remaining numbers to make 20. 7 plus 6. A is 7, and E is 6.
Well done! When you observe closely, hidden details come out through thinking. This helps you shorten the steps needed to solve a problem. This process is called building an algorithm. This careful observation is exactly what AI lacks. You build your own algorithm by paying close attention. And the algorithm you build now will stay with you for a lifetime, with very few exceptions. Keep this in mind and always try to observe carefully to build a solid algorithm. In both problems, we didn't stop at our first thinking, but looked closer to find the answer. In problem 1, it is easy to miss that there are two possibilities. I plus 2 equals 10, and I plus 2 equals 20, within the condition when the carryover is 2. In problem 2, we realized that the thinking, the carryover can be at most 1, didn't fit this problem. And we re-examined the ones place. When the carryover is 2, could there be another possibility within that? This question helps students realize that sometimes a single situation needs to be broken down further. Does a carryover always only go up to 1? This question shows students that they were blindly applying a rule that only works when adding two numbers. Once C is chosen, why did one possibility for D disappear? This question helps students see that finding one place is used to narrow down other possibilities. Great job finishing Lesson 8! Before moving on to Lesson 9, watch the logic flow lesson linked to this series. It will help you understand the next steps much more clearly. Check out Logic Flow Lesson 5 below.